Okay, Mr. Baumer here. Continuing in Chapter 9, all right? We are continuing, again, let's remind ourselves where we were. The first half of Chapter 9, what we were doing was graphing quadratics, all right? The second half of Chapter 9, what we're doing here is working on various ways to solve quadratic equations. All right, and so far we've learned two. Today we're going to learn a third method, all right? We're going to continue to practice that in class. Now, let's think about this for a second while you're writing down the objective. Student will be able to solve quadratic equations by using the quadratic formula. All right, that's the objective today, is that you learn about this thing called the quadratic formula, and we'll want to learn why it's useful, why we need it, all right, and how to use it. All right, so again, the objective. Student will be able to solve quadratic equations by using the quadratic formula. All right, now let's look at something here for a second. The two methods we have already learned, one of them graphing and the other factoring. Graphing. Now, how would you solve this by factoring? Well, if you remind yourself, and I know we didn't spend much time on this because we spent a whole unit on graphing that I was tying our factoring to the graphing the other day in class, but we would, if we had to solve this equation, right, 0 equals 2x squared plus 5x minus 4, we would change, if we were going to use graphing as a technique to solve it, we would change the 0 to y, and we would graph it, and we would look for the zeros. All right, those are actually the values of x that produce a y value of 0. Now, I want to point out to you some of the shortcomings of these two techniques. All right, graphing. Well, if you look here, our zeros here are a little to the left, meaning a little to less than -3. And over here, it's like, it's somewhere between 0 and 1. All right? So if you're graphing by hand, one of the shortcomings of graphing is you may be very imprecise, all right? You may not be able to tell exactly where it is. Now, these days with graphing technology, such as I made this graph on a graphing calculator, I could actually get my graphing calculator to calculate what is that exact value right there, and what is that exact value right there, all right? So with the power of computers, graphing becomes a very powerful tool. Again, but we're trying to graph these by hand in class, and when we do that, we may end up being imprecise. All right, now, what about factoring? Well, let's look at this. If we were trying to solve this equation by factoring, we would first of all say, all right, is there a greatest common factor? No. How many terms are there? There are 3, so we should try the x factor. And we'd be saying, what are the factors of -8, that's 2 times -4, that add up to +5? Now, if they multiply to be a negative, one has to be positive and one has to be negative, we would find that there is no answer to this, all right? Meaning this expression cannot be factored. So if this expression can't be factored, obviously factoring is kind of going to let us down here. Now you may say to yourself, then why would I ever use factoring? Let's not forget, when an expression can be factored, factoring is a very efficient, very quick, pretty easy method for solving quadratics, all right? So, I mean, this is actually, on a personal level, this is where the way I go with all the time, all right? If an expression can be factored, I'm going to use it every time. Now, what we need, though, is a method, because, again, this has some times when it really won't work for you. This has some times when it really won't work for you. We need a method that works for us all the time. And that method is the quadratic formula. Now, if you're about your age, some of you start thinking, well, wouldn't it be cool to have a tattoo? Now, if you're going to get a tattoo, maybe this is the one you get, right? And obviously, I'm just kidding. But, all right, the quadratic formula. We need to know, what is the quadratic formula? Well, the quadratic formula is... here it is, x equals -b, so that's the opposite of b, plus or minus the square root of b squared minus 4ac, the entire thing, over 2a. All right, so that is the quadratic formula, and you need to memorize. All right, you got to get this tool in the toolbox. All right, you need to memorize this formula. How are you going to use this formula if you don't know what it is? All right, so you will need to memorize this formula. Now, make a flashcard, take some action to make it, stick in your head. So, now let's talk about how we use it and why it's useful to us. So the first thing I want to do is, before we even start to solve, look right here, we have a quadratic equation here to solve. All right, there's part of the quadratic formula, and in fact, the part I'm talking about is right here. All right, so let's make this a little bigger. Let's go over into the background section. If we're looking at the quadratic formula right here, this part right here, the part that's underneath the square root symbol, is called the discriminant. It's called the discriminant. All right, and it tells us something. All right, it tells us how many solutions we'll have. Now you may say, wait a minute, how many solutions I'll have? But let's not forget, when we were graphing quadratics, all right, one of the questions I kept asking you was, how many zeros does this quadratic have? Sometimes we found that we had 2. Other times we found that we had 1. And other times we found that we had, for instance, 0 zeros. We had 0x intercept. So in the related equation, we would have 2 solutions, 1 solution, or no solution. So it's like this. If I'm on a treasure hunt, if I'm setting out to look for treasure, if I'm setting out to look for answers here, I'd kind of like to know how many I should be looking for. That way I don't keep looking after I've found all of them, or I don't even bother looking if I know there aren't any. All right? So what does this tell us? Well, the value of the discriminant. Let's look at this. If you're taking the square root of a positive number, how many answers are you going to get to that? Well, for instance, the square root of 4. How many answers are there to the square root of 4? Well, 2 is the square root of 4, but negative 2 is also a square root of 4. So what you need to know is that when the value of the discriminant is positive, that really tells you you're going to have 2 real solutions. Well, when the value of the discriminant is 0, what if b squared minus 4ac was 0? Well, what's the square root of 0? The square root of 0 is 0. Now look here, plus or minus. That means, then this plus or minus, what does it do to add 0 versus subtract 0? Well, there's no difference. So when the value of the discriminant is 0, you're actually going to have 1 real solution. But what if the value of the discriminant is negative? All right, what's the square root of a negative number? Let's think about that. The square root of, say, negative 9. Is there any number we can multiply by itself to end up with a negative number? No, because a positive times a positive is a positive, and a negative times a negative is a positive. So until we start introducing you to the idea of imaginary numbers, when the value of the discriminant is negative, we're going to have 0 real solutions. So I mean, that's something to look at before you start to solve a problem. I'd like to know how many answers I might find. Now, let's try and solve this one. Let's try and solve this one right here. Find the number of real solutions of each equation, then find the solutions. So, the first thing we could do, because this whole formula is based on a, b, and c. Now, we're not going to know a, b, and c until we put this in standard form, meaning, and you have the steps down here at the bottom, I guess on the next page, but the first thing we want to do is set this thing equal to 0. So I'm going to move this negative 2 to the other side. That's going to make the equation 3x squared plus 10x plus 2 equals 0. Now I can identify the values of a, b, and c. A equals 3, b equals 10, and c equals 2. Now, let's find the value of this thing called the discriminant so that we know how many answers we'll find. If there aren't going to be any answers, let's stop right there and not go looking for them. So, what is b squared? And again, this comes back to my favorite date, right? August 21st. B squared minus 4 times a times c. And what do we put in there? Again, that's b squared. So that's 10 squared minus 4 times a, which is 3, times c, which is 2. Now, this gives us 100. This gives us, what's 4 times 3? That's 12. Times 2 is 24. So minus 24. So 100 minus 24 equals 76. So since the value of the discriminant is positive, we should end up getting 2 answers to this question. So let's set out to find those 2 answers. Now, you'll notice here, again, my favorite date, right? August 21st. What have I done? I have taken the quadratic formula, and the only thing I've done is replace the variables with parentheses, so that now I know I'm going to find 2 solutions And now I'm going to start filling in those values. So what goes there? Well, the quadratic formula, that's b. All right, so it's b. Well, b is 10. And this parentheses is very valuable because a lot of students, unfortunately, will put, if b is negative, they just write a negative 10 instead of realizing that it's the negative of negative 10 on another problem. All right, so I just put 10 in there. I also put 10 there because it's b. Here, what do I put? Well, I put 3, and here I put 2. And down here, because it's a, I put 2 again. Now it's all about simplifying now. So let's start simplifying. What's the opposite of 10? It's negative 10. Plus or minus. Now we already figured this part out once. We already figured that this number was 76. And we're going to divide that whole thing by 4. Now, what does that give us? Well, right now I just want you to estimate the value of the square root of 76. All right, so if you were to do that on your calculator, if you were to estimate this, then we would be getting negative 10 plus or minus approximately 8.72. We're going to divide that whole thing by 4. Now, what does that mean we need to do? What does this plus or minus symbol really mean? Well, it means we really have two equations. First, we have to add it. So I'm going to take negative 10, and I'm going to add 8.72. And then to that answer, I'm going to divide by 2. So the answer I get when I'm adding, all right, so when I'm using the plus symbol, all right, the answer I get is negative 0.64 approximately. All right, so approximately, let's make that a squiggly equal sign. Or, now when I'm using the minus symbol here, let's see what I get. So now I'm going to do negative 10 minus approximately 8.72, and then I'm going to divide that answer by 4. And the answer I get there is approximately 4.68. Right, so again, I knew I should find two solutions. I did find two solutions. Right? Now, let's flip over to the next page. How would we solve this? All right? How would we solve this? Again, we could look at the discriminant. We're going to practice that in class a little bit more. But how would we solve this? Well, I better write it in standard form, which would be 2x squared plus 3x minus 5 equals 0. And now I can plug in my values, because what goes there? B. Well, B is 3. What goes there? B, because B is 3. What goes there from the quadratic formula? All right, it's A, which is 2. What goes here? That's C, so that's negative 5. And what goes down here again? That's A, which is 2. Now it's all just a matter of simplifying. What's the opposite of 3? It's negative 3. Plus or minus square root of, this is 9. And now what I do is I count the number of negative symbols. Here I got one negative symbol and another negative symbol. So I know the value of just this thing right here is going to be positive. So then I just do the math of the numbers. What's 4 times 2? 8 times 5 is 40. Now that whole thing should be over 4. So now we have negative 3 plus or minus the square root of 49, that whole thing over 4. Well, what is the square root of 49? Well, the square root of 49 is 7. So I really now have negative 3 plus or minus 7, the whole thing over 4. And again, that plus or minus is going to produce two answers. What's one of them? What's negative 3 plus 7? Well, that's 4. And 4 divided by 4 is 1. So one of our answers is 1. And the other one, let's come back and do the negative. Negative 3 minus 7 is negative 10. And negative 10 over 4 reduces to negative 5 over 2. Those are the two solutions to this quadratic. So, again, working with the quadratic formula, you have to memorize it. All right? You have to know the formula if you're going to be able to use it. And we're going to practice this a lot. But some of the takeaways I want you to think about today. The quadratic formula needs to be memorized. The quadratic formula will work every time if you do it right, that is. All right, and then we'll talk about that in class. A lot of students want to use this all the time because they know it works all the time, but it can be difficult for some students to use. And don't forget that the value of the discriminant tells us how many solutions we will find. All right, so we will see you in class.